high-level languages. As you know, computer cannot understand human languages like English, Hindi, Telugu, etc. and all that. That's why we must learn computer languages. Computer languages, and computer languages, there are dozens of computer languages, and these languages, some languages are directly understandable to the computer, and some languages are not understandable to the computer directly, then translation process is required. Now, if you classify this low level and high level, low level languages are machine languages. Machine languages. Machine language, actually computer's language is binary. Binary. So it can understand 1 and 0 only. Any code, suppose A, if you want to give A, character A to that, and it should be a specific code is there for this, that is D. So you have to provide it in a binary code. Binary code, then only it can understand. This is according to ASCII code. For A's corresponding code is this one. So in case of machine languages, a computer, while it is developed, if the processor is designed in such a fashion, all the basic operations is converted into machine code and incorporated in that. This is totally mission specific, mission dependent. Whatever code they develop for that CPU is workable for that computer only, for that type of computer only. On other computer it does not work. So for every computer, specific mission codes or unique mission codes are created for all the basic operations. So every mission code is understandable by the computer directly. It can execute it very easily. But these are very difficult. Those are strings of numbers, big strings of numbers and all that. Ultimately, those are converted into ones and zeros and all that. Suppose, let us take an example. SP, selling price. Selling price is equal to CP, cost price, plus profit. Suppose if we have to execute this and all that, then a big string of numbers are to be used in the machine code. Then ultimately those are reduced to ones and zeros. Machine can understand them because its CPU is designed according to those codes and it implements it very easily and all. But as far as humans are concerned, it is very difficult to understand those strings of numbers and all that. That's why thereafter, as in order to make it easy to the humans and all that, and assembly languages were developed. Assembly languages were developed. Here, what is the difference? Whatever the numeric codes are used and all that, those are transformed into small short forms of English, like add, load, store, like this. Like this simple form of English words are developed, abbreviated words are created. These are called mnemonics. So then actually these are not directly understood by the computer. For this purpose, one software program is used, that is assembler. The assembler ultimately converts all these short forms into machine code. Then machine can understand and implement them. Now we see, with reference to this example, how assembly language code is implemented. Let us see. Now load CP, load cost price, add profit to that. Then what is created? SP is created. Then store SP into specific place, specific memory location. This is the way assembly language. So compared to the machine language, for humans assembly language is easier to understand. But for language is also very difficult. But a computer can understand these two languages directly or with a little operation, then these are executed faster. But how humans are enabled to understand these languages properly, speedily? For this purpose, high-level languages are created. High-level languages are created. High-level languages, example, C, C++, Java, etc. High-level languages we use almost short forms of English, all numbers, whatever we use in mathematics and mathematical symbols, all that we use. Suppose this formula is used. In a high-level program, you write it like this only. This is like cost price plus profit and SP, like that you write. So then humans can understand them very easily, and they can write code very easily and all. Now this is, but here one problem is there. These codes are very easily understandable to the human being, but computer cannot understand. For this purpose, one translator software is to be engaged, that is compiler. The translator software is called compiler. Just for example, now you do not know English, I do not know Hindi. Now you want to learn C language from me and all that. Then what should we, if I can teach in English, you cannot understand. If you ask any doubt in Hindi, I cannot understand. Then what is the way out? Then we appoint a translator who knows both English and Hindi. Then the problem is solved. Problem is solved. But here one issue is involved. What is that? Suppose to teach this concept, if I take half an hour, provided if you know English, and now because of translation process, it may take higher time. Now it may take 1 hour even, because whatever I speak, everything the translator has to translate in Hindi. Whatever you ask, any doubt and all that, again it translates back to English and all that, then I have to explain. Because the compiler plays the translator software role, the translator of the codes and all that, that's why it requires more time. So if you consider, program development consists of two times. One is coding time, second one is execution time. As far as low-level languages are concerned, coding time is more, because for who will write code? Human being, programmers write. Writing code in this is very difficult. That's why they take more time. But execution time is very less, because these codes are directly understood by the computer, and computer executes it faster. So this is less. As far as high-level languages are concerned, coding time is less, because all these codes are like this. Those are human readable and understandable format, and simple numbers, whatever symbols we use in mathematics and all that we can use. That's why humans can understand them very easily and remember and write the code very easily. And here one more time extra. What is that? Compile time. Compiler takes lot of time to translate each and every bit of every code in the program. For that, it creates millions of operations and all that. So compile time is more. Of course, after compilation, what is created? Machine code is created. Then this time is same. Execution time is same, but compile time is extra. That's why comparatively with the low-level languages, high-level languages are inefficient. But low-level languages, coding is difficult and execution is simpler. In high-level languages, coding is simpler, execution time is same, but compiler time is extra. That point you have to understand. So when we compare both the low-level languages means assembly language, actually one process assembler is engaged. Assembler, every suppose load, it immediately translates into machine language, and in the similar manner add and store also. So this is the way you have to understand. Now let us compare both low level languages and high level languages. Efficiency wise, low level coding is inefficient, execution is efficient. High level languages, coding is efficient and execution, including compile time, it is inefficient. That is the thing. And low level languages are mission dependent. Mission to mission, the mission codes are different. That's why it is not portable. High level languages are highly portable. Highly portable. And third one is program coding. Coding in low level languages is very difficult and error prone. In high level languages, coding is easy because it is almost a human understandable format. And low level languages, the memory space requirement is very less. But in high level languages, because so much translation coding is there and all that, for that purpose it requires more space. As far as debugging is concerned, low level languages debugging is very difficult because it is not a human understandable format. That's why debugging is very difficult. In high level languages, debugging is comparatively much easier.